Well, hello, everybody. Really good to see you all. I'm very excited to be here doing this talk. It's such a lot of people. It's pretty cool doing a talk in a stadium. I was expecting a halftime show by Beyonce, but I don't know, she's double booked or something. So what we are going to do today will hopefully be more exciting still than that. So my name is Steve, and I work at Microsoft. I'm on the ASP.NET team there, and primarily my job is to try and make stuff as good as possible for people building rich JavaScript applications. So we want ASP.NET Core to be the best platform for people doing Angular, React, Knockout, that sort of thing. And we are releasing some stuff to try and make that better for you, and that's what I'm going to talk about today. So before we get into specific bits of the technology, let's think about the technology landscape that we're all dealing with today. So how many of you are doing ASP.NET Core development of one kind or another? Yeah? All right, so maybe like a third of people. How many people doing ASP.NET of some other sort? Yeah, okay, so a good, like, more than half of people. All right, then. So when we speak to ASP.NET developers, or I'm saying ASP.NET Core here, but it really applies to everybody, we hear very, very often that people are doing a lot of stuff with one of these single-page application frameworks. So whether it's something like Angular, React, Aurelia, other things like that. Another show of hands, how many of you are using one of those technologies right now in some part of your work? Okay, that's a good half of you, which is what I would expect. So people tell us that they're generally pretty happy with this sort of thing, but they also tell us that it's kind of complicated because there's a lot of stuff going on that they have to do. So as well as knowing about their frameworks, of course, they need to know about various different languages that they may be having to compile to JavaScript. TypeScript's very popular, but also if you're writing modern JavaScript, you need to transpile it so that your browser can run it. People also write their styles with various different syntaxes and technologies. Sass, post-CSS is gaining popularity, that sort of thing. And for these things to actually run in your browser, you need to transpile them in some way. And there are many different tools for dealing with front-end build systems. Webpack is dominant at the moment, but there's also some slightly more old-school things like Grunt and Gulp still going strong. And it doesn't just stop there. There's also things like different types of application architectures that people are working with. Now, you may have never heard of MobX or Redux or Flux. It doesn't really matter. That's not really important for this talk. I'm just saying that these sorts of things are out there and constantly pushing the boundaries of what we're supposed to know. And then, of course, we get to testing, and you might want to write end-to-end tests with a full testing stack like Karma, or you might just want to write some unit tests with Mocha or Jasmine, and that's all good. But it does sort of raise the question of, to be honest with you, do you really love all that? I mean, it's a lot of stuff for you to try and deal with, and developers do say to us, I mean, seriously, this is so much stuff. Is there not some way that we could make this a little bit more streamlined, maybe? And so that's something that we're trying to do on the ASP.NET team at the moment. And one thing that we've shipped just in the last month is a nice system for creating projects on ASP.NET Core with technologies like Angular, React, and so on. And the idea is to be a nice pre-packaged box that's got all the pieces in it, that is all fitted together in the right way already, so that you're going to have a good time when you start trying to actually build your application. And I'll be showing you quite a bit of that during this talk. And if you want to get this and use it yourself, you'll find the project templates I'll show you are currently shipping on Yeoman, which is a Node-based project creation system. And they are also available to plug into the .NET New command line, which is what I'm going to demonstrate in just a minute. Now, project templates on their own are not a complete solution to everyone's problems because everybody wants to do things in slightly different ways. So as we've been designing this, we've been making sure that it's possible to open the box and get at the components that are inside there so that you can restructure things and do stuff in your own unique way. And so we are also shipping some NuGet packages that contain a bunch of the functionality I'll show you today, and also some NPM packages. So in general, the .NET code goes into NuGet packages, and the JavaScript code goes into NPM packages. That's generally the way it works. Okay, so I'm going to show you quite a lot of this stuff during this talk. And in fact, let's just have a quick overview of how we're going to structure the next 55 minutes or so of your lives. Well, we're going to split it up into three main sections. Firstly, I'll show you this sort of friendly out-of-the-box experience of building a nice single-page application with these project templates and all the cool stuff you can do there. Then we'll dig a little bit into Webpack itself, because Webpack is really central to how a lot of this stuff works. It's very powerful and effective when you get used to it, but some people find it a little bit intimidating at first, and I'll hopefully talk you through it and make you feel good about it. And then finally, we will really get deep under the hood, and we'll see how some of this stuff works internally with a package called Node Services that I will explain when we get to it. All right then, so for this first section, we're going to go through the process of creating a couple of little single-page applications and seeing some of the features that are going to make your experience as a developer better than they would normally be. So we'll get started with getting started, of course. And as I just said, these project templates are available for Yeoman and for .NET New. Now, we might do Visual Studio templates at some point, but at the moment, for shipping them as fast as we can, we're making these available through these command line project creation systems. So if you've used .NET Core at all, you'll probably be familiar with the .NET New command that you can run on a command line. And that will create different types of project for you. So out of the box, we can create empty ASP.NET Core web applications, web API, that sort of thing. Okay, that's all good. But there's nothing in there for creating a React application or an Angular one. So that's not too helpful. But the .NET New system is extensible. You can plug extra project templates into it. And so we have just shipped, in the last few weeks actually, this project template package that you can install. So if you've got the .NET tooling RC4 or later, you can run this command, .NET New install, and then we'll give it the package of templates that we want. So that's Microsoft.ASP.NET Core.SPA templates. And we have to tell it which version we want. So we've got this slightly funky syntax there for saying, just give me whatever the most recent version is. And that will install these templates that I'm going to show you now, if you've got an internet connection, which I am not relying on right now. So I have got the packages locally, and I'm just going to install them from this file that I've got here, but you would do it off the internet. And now I've done that, you can see that we have now got the ability to create ASP.NET Core applications with Angular, really a knockout, blah, blah, blah. Okay? So let's have a go at doing one of those and see what comes out of it. So I'm going to make a new directory, make dir my super app, okay, and then I'll go into there, and now I can run .NET New Angular. And that's going to create a new starting point for a really well-featured ASP.NET Core application with Angular. And if we look, we'll see there's quite a lot of files that have come out of there. It's kind of difficult to make sense of if you just look at it in the command line, so I'm going to switch over to Visual Studio. And over here, I've got a couple of projects that I've already created and restored all the dependencies for, but it's basically the same as what you will get out of that command line tool. Also, I'll just point out there's nothing in this talk that's specific to Visual Studio. Everything that I show you here is fully cross-platform and will work just as well with VS Code or Notepad or whatever it is that you're into. But I'm just using VS because it's quite nice. Okay, so this is the project that's coming out of there initially, this My Angular app. And you can see that it's pretty much a normal MVC kind of application. It's got all the usual sort of controllers and views and program and startup and all that sort of thing that we normally see. But it's also got this client app directory. And if we look in there, we'll see various things that are to do with Angular. Okay, we'll have a look at that code in a second, but let me just start it running in a browser so we can see what we've actually got there. So I'll press Control F5 to make it pop up in a browser, and it'll take a couple of seconds the first time that it comes up. But when it does, you will see that we've got a fairly basic kind of application that you could start to add your own stuff into. So it tells you a little bit about the technologies in there. We've got some simple navigation type stuff. I can do backwards and forwards. That's client-side navigation there using Angular's router. And then we've got a couple of simple bits of functionality, like we've got an example of how to fetch some data from a web API backend and display it. We've also got a simple example of an Angular 2 component where we can just click a button and it will increment this little count thing there. So not too fancy or clever. Let's just quickly see the source code that's behind some of this. So for the counter that I just showed you, we've got this directory here. This is Angular 2 or soon to be Angular 4, whatever number they give it this week. It doesn't really matter. It's the same framework. And we're looking here and we can see the code for the counter thing. And we've got two files. We've got a TypeScript file and an HTML file. Let's see what's in those two, shall we? So first, we'll have a look at this TypeScript file. If I zoom out a little bit, we will see that we've got TypeScript, as you'd hope in the modern world. It's using this import statement to reference the Angular library. It's using this annotation here to tell Angular to treat this as a component that can go into the user interface. And then our class is very simple. It just says, OK, we'll have a property to track how many times you've clicked. And whenever this method gets called, we're going to increment that count. Pretty straightforward. And that is wired up to this HTML template here. And if we look in there, we'll see it displays the current count, and then there's a button that when you click it, it's going to cause the count to increment. Very straightforward. Right, now we're not limited to doing stuff with Angular. Like I said before, we've also got templates for Aurelia, for Knockout, for React, and for React with Redux. We might add others as well in due course. Those are what we've got right now. Let me show you the same thing with React and Redux. I bet not many people are using Redux, but quick hands up if you are. Oh, that's more than I would have thought. That's probably 5%, maybe a bit more. OK, so Redux is an application architecture that's often used with React. It's quite a formal system for building an application, but it's very powerful. I'm not going to go into it in too much detail, but just to quickly show you, let's start up this Redux app, which is the same thing, creating a new project, choosing the Redux template, and initially it will look basically the same as we got from Angular just there. So it's got the same 3 things that we can navigate about between. It's got the same little count thing there that I can click on. And in terms of the code, well, like I said, Redux is quite a formal system for building an application, and it requires you to separate your application state from your user interface. And the application state lives in a thing called a store that tracks all the data but isn't the user interface. And for example, the store for the counter looks like this. There's a lot of boilerplate code that you can just ignore. The only bit that matters, really, is this bit right now. So that's defining the type of the data that we're actually going to be storing here and that can change over time. And then if we scroll right down here, this bit's relevant as well. This says that there are 2 things that can happen. We can either increment the count or we can decrement it. When the user wants to increment, we will change the state to be 1 more than before, and vice versa, we will change it to be 1 less than before. So that's just the application state. And in terms of the user interface, we have this React component that gets bound to that. And this produces this HTML here. So it displays the current count value. And when you click this button, it's going to cause that increment event to occur. And that will change the state of the store. OK, pretty straightforward. If you don't know Redux, don't worry about it, because I'm not going to be talking about Redux any more than that, really. Just was showing you that it's there. OK, so that's getting started. You can install these project templates into .NET New, and you can then create a new project. You can see the basics of the code that's in there. And you can start building your application that way and following those patterns and make something large and sophisticated and make loads of money. But if that was all there was to it, it wouldn't be very interesting, really, would it? So what I'm going to show you is some of the cool things that are in there that you wouldn't normally expect to get out of the box with a new project, things that will make your life as a developer a lot more joyful than it otherwise would be. And we'll start with Webpack and a particular feature called hot module replacement. So what's Webpack? Why do we need it? I think most of you probably have heard of Webpack by now, but just in case you haven't, it's a build system for front-end applications, a bit like Grunt or Gulp, but more modern and arguably more advanced. And it's got some really nice functionality in there. This allows us to do everything we need to transform all our source code into something that can run on the browser. And we need that, of course, because our source code is lots and lots of little files of types that the browser doesn't necessarily even understand. So in this Angular application, I've got lots of TypeScript files for all the different components. I've got lots of HTML files for all the different views and so on. And these things all have to be bundled together in a sensible way and compiled and so on. So Webpack takes care of that for us. We'll talk more about how that's configured later. But one cool thing about Webpack is that unlike most compilers, when you run it, it doesn't necessarily just exit. It can, if you want, keep running in the background and watch for changes to your source code, and when it changes, automatically push those changes to the browser so that your application just updates without you even having to reload the page. And we've integrated with that in these ASP.NET Core templates there, so you don't have to do anything particular to set that up. That's just ready to go, and the stuff will all flow through your ASP.NET application. So to show you that, I'm going to make a change to this counter component here. I'm going to do it so that we can see both Visual Studio and the browser at the same time. And I'm going to change this. So let's change the text here from counter to super counter. And when I click Save up here, we'll see that in the browser, I don't even have to switch back to the browser, but it's just going to update on its own. So it just changes to super counter there. And it's not only markup that I can change that way, it's also code as well. For example, you can see that we've got this current count of 6 right there in the browser right now. If I wanted to change it, I could say, all right, instead of displaying the current count, I'll display the current count times 2. And then when I press save, you'll see in the browser that 6 becomes a 12. So we haven't lost our application state. We didn't have to reload it. We're just changing the code on the fly and injecting it straight into the browser. I could even implement some entirely new functionality while my application is running there and see it happen. So let's say I want to have another button next to this one that decrements the counter, that decreases it every time I click. So I could take this button here, and I'm just going to copy this, and I'm going to paste another one down here, and I'll say, when this one gets clicked, we'll call decrement. Now, we've got IntelliSense, because it's all TypeScript there, and I'll press save, and we should see the new button will show up in the browser automatically thanks to the hot module replacement. I need to change the text on that, so I'll change that to decrement, and I'll hit save, and you'll see that the text on the button changes there. And so now I can go up and down by clicking these buttons. Didn't even have to reload the page. It also deals quite nicely with things like syntax errors, because of course you're going to make some mistakes sooner or later. So what happens then? Let's say I try to call a method that doesn't exist. I'm going to call blah. Now, Visual Studio knows that that's not a real method, so it's going to display the red squiggly stuff to me. But let's say I just ignore VS and I press save anyway. What's going to happen? Is it going to break my app? Well, I now get this message in the browser, property blah does not exist. Okay, so let's fix that, shall we? So we'll change that to decrement, hit save, and then my application will come back, and it's still running, it's still got all its state in memory, and we can just carry on with what we were doing. So this is a really nice experience for you as a developer. You've got this live link between your IDE and your application that's running in the browser, and that is thanks to the fact that we've got Webpack and that we've integrated it with ASP.NET Core at runtime there. Okay. Now, next thing I'm going to show you is a very cool feature called prerendering. And the idea with this is, wouldn't it be interesting if your Angular components or your React components or whatever, now normally they're JavaScript and they can only run in a browser, which is a bit limiting, isn't it? Because sometimes you might want to run stuff on the server as well. Wouldn't it be interesting if your components could run both on the server and on the browser, even if they could initially run on the server to be rendered into their initial state, and then we could send that running application down to the browser, where the browser would pick it up and continue the execution where the server left off. That would be pretty cool. Now, until fairly recently, there was no reasonable way of doing that, but because of changes in Angular and in React and in Webpack and so on, this is something we can now put together, and this is built into these projects. So let's see that working, shall we? I think the best way to see this working is probably to turn it off and see what problems happen if we don't have this, and then we can see what benefits we get when we do have it. So first thing I'm going to do is I'm going to disable the server-side pre-rendering, and I'm going to do that by going into this particular view in my ASP.NET application. This is my index view that runs when my application starts up, and it's got in it this app element, and that's where my Angular application is going. So to disable the pre-rendering, all I have to do is remove this tag helper that tells ASP.NET I want to do the pre-rendering. I'll talk about what that does later, but let's just get rid of it for now, and I'll press save. Then I'll go back to my browser, and in my Angular application, I can hit reload. And it still works, you know, it's completely working fine, but now it's a purely client-side application because I've disabled the server-side pre-rendering. So if I hit reload a few times, you'll see in the top corner, you can see that message loading. And it takes about 1 second or something like that to load. So what's going on during that time? Well, that is the time when my browser is fetching all the JavaScript from the server, both for my code and for Angular, and it's parsing all that code, it's executing it, it's building up this initial set of DOM elements, and it's sticking all those DOM elements into the DOM, and then it's rendering the page. And all that together is taking about 1 second. And you might think, hey, 1 second, that's not too long, is it? That's pretty good. I don't mind if my users have to wait 1 second for my application to load. But in the real world, it's not going to be that fast, Because in the real world, your end users are probably not running your application on localhost. That's kind of an artificial scenario. And a lot of them probably don't even have particularly fast laptops like this one. They probably are running it on some low-end mobile devices in a lot of cases. So how slow is it really going to be for them? Let's find out. We'll simulate it. So in the Chrome DevTools here, I'm going to go to Network tab here, and I'm going to say I want to throttle the network so it behaves like, let's say, regular 3G. So 3G is supposed to be reasonably fast, isn't it? So we would want it to be able to perform OK over 3G. And I'm also going to pretend that I've got a slow mobile device. So I'm going to throttle the CPU down to 1/5 of its normal speed to simulate a mobile device. And we'll see how quickly or slowly the application loads now. So just to see that, I'm going to first clear this page, and then I'm going to go back to that URL. So I'm going now, and we will see how long that takes. So we're waiting for it to load, and we're still waiting, and we've got the loading message now. That's good, but we're still waiting, and we're still waiting. We're still waiting. We're hoping this comes up fairly soon, that it hasn't actually broken. Is it broken? We don't know yet. Oh, finally, here it comes. OK. Now, you couldn't see the timings there, but it took about 20 seconds for that to come up just now, which is much too long. OK? That is not what you want for your application. There are many ways that you can make your application load a little bit faster. For one thing, this application is not even minified right now. So we could certainly reduce the time that way. But still, people have thought for some time that a fairly fundamental limitation with these rich single-page application frameworks is that it's quite heavy, and you're putting a lot of load on the browser. And in fact, there's an even worse scenario, okay? This is like our worst nightmares. This is what keeps us awake at night. Can you imagine this, right? Somebody doesn't even have JavaScript enabled in their browser. What's going to happen now? OK, let's see what kind of end-user experience we're offering to our paying customers now. I'll hit reload, and we'll see what do we get. We get the word loading, and it's just going to stay there forever now. It's not really loading. It's lying to us. It's a bad user experience. OK, now, historically, that was a fundamental problem with JavaScript-based applications, but because of pre-rendering, we can now do something about that. So let's say we want our application to run on the server as well on the client. So I'm saying, ASP.NET, I want you to pre-render this JavaScript module here, main-server. And inside there, there's a bit of logic that knows how to start up an Angular application. There's an equivalent one for React and so on. So if we put that there and we go back, now when I reload, my application will be running on the server as well as on the client. So I'm reloading now, and I still don't have JavaScript enabled in my browser, but my application can now come up, which is a significant improvement from before. And I can even do some stuff like I can navigate around, because those are just regular HTML links. Now, not everything is going to work with JavaScript disabled. It's not meant to. For example, this button will do nothing if I click on it, because that's just wired up to some JavaScript code. But the point of this is not really to run without JavaScript, because that's a very artificial scenario, and you probably don't really need everything to work in that scenario. So I'm going to put JavaScript back on. The real point of this is to make sure your application loads very quickly. So it should come up within 1 or 2 seconds, even though you can't really see, but it is. It's coming up in about 1 second, even though I don't have, even though I've got a simulated very slow network connection and a simulated very slow CPU. So I will just make sure that you can see that. So I'm clearing the page, and then I'm pasting the URL back in, and now my application comes up in, what has it taken? Taking a longer time than usual there, 4 seconds. Normally, it's quite a bit faster than that. Anyway, the point of this is to be able to bring up the UI very quickly, even if you've got a slow network connection, even if you've got a very large application, even if the user's on a very slow mobile device. So they see the user interface more or less straight away, and then the JavaScript loads in the background. And when the JavaScript is loaded in the background, then it will take over, and the application becomes fully interactive like before. So that's makes your application significantly nicer for many of your users to use. That's pre-rendering. OK. Next thing, deployment. This one, I'm not going to demo to you because it's really boring, but basically, you can imagine what this is going to be. At the moment, I've got an unminified development mode application that loads lots of files, it loads source maps, all that sort of thing. You wouldn't want to ship all that stuff in production. Well, don't worry about it. The way these projects are set up is when you do a publish, either from VS or from .NET command line tools, we will do a very efficient Webpack build of your application. Everything's tightly minified and bundled and everything like that, and it's going to perform as well as it can in production. So that's just, it's in there. You can trust me that that works, but it's too boring to actually demo. Slightly more interesting, debugging. Now, I'm sure at some point or another, you're going to have to debug your code, and the code that you're writing here is mostly TypeScript. So how can we debug TypeScript? Because TypeScript is not actually running natively in the browser. TypeScript has to be compiled to JavaScript, so it could be a bit annoying if you are trying to debug that, but thankfully, it's not that annoying because of a feature called source maps. Source maps is a technology that allows the browser debugging tools to show us the original source code rather than the compiled code and let you debug through it. And that is all set up out of the box here. So if I want to debug this counter thing, I can say, let's have a look for the counter component here. And you'll see in my browser, I can now get the original TypeScript source code there. I can do things like set breakpoints on it, and those breakpoints will hit when I trigger the relevant bit of code path. And I can inspect my application state and that sort of thing, and that all works correctly. So that's not hugely impressive. That sort of thing has been possible for quite a while. A little bit more interestingly, what about Visual Studio-based debugging? A lot of developers tell us they want to be able to set breakpoints right in their code editor at the place where they originally wrote their code. And that used to be kind of difficult to set up, but now it's all just ready to go for you. So I've put a breakpoint there. I've now pressed F5, which is going to launch my application with debugging. And Visual Studio knows how to work with Chrome so that it can connect to the Chrome debugging engine and exchange messages about the running application there. So when that comes up with the debugger connected, I should be able to go to the counter and click this button, and then the breakpoint will hit inside Visual Studio there. And I could press F5 and it will continue. I could click it again. And I could even do things like inspect and modify the application state. So down here you'll see we've got the current count property, which is currently the value 1. We could even modify that in VS. Let's say to 1,000, and then when I press F5 to continue, then back in my browser, you'll see it's now gone up to 1,001. So we've got full integration of the debugger there. Now, it's really easy in Visual Studio because you just press F5 and it works. If you're using VS Code, you have to do a little bit more clicking on menus to set that up, but it's all fully documented. It does work there as well. Okay, so that's debugging just ready to go for you out of the box. So I'm turning off the debugger there, and I'm starting the application again without the debugger. Okay. Last of the features that I'm going to show you from these templates now is tests. Now, I know some people like to write automated tests for the JavaScript UIs, and some people do not. That's fine. It's entirely up to you. For those people who do, often it's regarded as yet another annoying thing to try and set up. So again, that's ready to go out of the box here. Or at least it is in the Angular template. We've only implemented it in the Angular one right now because there's a very standard way of doing it for Angular. We may do that for React or others later if people give us a good enough reason to do so. So anyway, for the Angular template, how would we write tests for this sort of thing? Well, the standard in Angular world is a testing system called Karma. Karma is able to run specifications against your components in a real browser, and that's what we've got an example of here. So again, we'll look at this counter component, and it comes with a spec file, counter.component.spec.typescript. And if we look in there, we'll see some specification code. Bit of boilerplate up here that you can just ignore. The interesting bit starts here, and we say, okay, we're going to have a category of tests called counter component. And for each test in that group, we are going to create an instance of our counter component that we can run some tests against. And the first test says it should display a title. Okay, and to implement that test, what we're doing is we are doing a little query over that component when it's running to get a reference to this h1 header element, and then we can simply specify that it should initially have this text counter. Pretty straightforward. And similarly, we've got this other test here that's testing the behavior of the increment button. And we're saying it should start with 0, and then it increments by 1 when you click it. And to do that, first we grab a reference to this count element and check that the initial text shows 0. And then we'll get a reference to the increment button. We'll simulate a click on it, and then we'll wait for Angular to do all its stuff, where it refreshes all the application state and re-renders stuff or whatever. And after it's finished doing all that, we can then read the new state of the counter and check that it's gone up to 1. Okay? I'm going to run that now, just check that actually works. So to do so, I'm going to go into the directory that's got the Angular application in, and I'm going to run npm test. And that will run a little script that launches Karma. Now, the tests there are implemented in TypeScript, so they have to be compiled. Karma will pick up our Webpack configuration to do the compilation. It will open a real browser, it will send the tests into the browser, and it will pull the results back out of them. And we can see here that it's executed 2 of 2 tests, and they both passed. Good news, everyone. Okay. Now, another cool thing about Karma is a bit like Webpack. After it's finished, it doesn't necessarily just exit. It can also keep running in the background and watching for changes to your code so that whenever you change stuff, it will rerun your tests. And thereby, it gives you a sort of live view of the correctness of your code. And this is great if you're going to do some sort of test-driven development type thing. Let's have a go at doing that, shall we? We'll add a new feature to our application in a test-driven kind of way, and we'll see how the tests change as we're going through that. So I want to be able to see both VS and the tests at the same time. So I'm going to put my test window right up there, like that. I'm going to move VS down here, okay? And I'm now going to add an extra bit of functionality to this application. And the bit of functionality I want to add is a decrement button. So we already had one for the React application, but we haven't got one in the Angular application yet. We've just got increment. And I want to add a decrement there as well. So back in Visual Studio, I'm going to do it in a test-first way. So I'm going to first modify my test code a little bit. I will say, OK, also test the decrement feature. Okay. Now, how are we going to decrement stuff? How should that work? Well, I think there should be a button called decrement. So I'm going to say, let's go and look for a button called decrement button. We'll give it this class name dec, like that. And then I'm going to try and invoke click on that button. Now, that button doesn't exist yet. So when I press save, what's going to happen? Well, Karma will immediately spring to life, and it'll say, look, one of your tests just failed. Well, why did it fail? If we scroll up, we can see, cannot read property click of null. Well, that makes sense, because we're trying to click a button that doesn't exist. OK, let's make that button exist now, shall we? So I'm going to go into the view for that, and I'm going to add a button with class dec. Okay, and I'll give it the text decrement, okay, and I'll hit save, and what's going to happen, now it runs again, and immediately we can see our tests are passing again. So that's a good thing. But my tests are not really complete yet, because I haven't tested what the new count is going to be. So let's say, just like before, we'll wait for Angular to update stuff, and then we're going to check that the new count should have gone down from 1 to 0. So I'll hit save on there again, and once again, Karma jumps in and says, sorry, but your tests are now failing. Why are they failing? Well, because you were expecting to get the value 0, but you actually got the value 2. Why did that happen? Why has it gone up when it should have gone down? Well, it's still calling the increment method, so that makes sense. Let's change it to called decrement, so I'll hit save. Now that's going to cause all kinds of errors because there is no method with that name, so it can't even execute my tests anymore now. And if we have a look, we'll see decrement counter is not a function. So we will go in here and actually add decrement counter, and let's name that properly. Decrement counter, and we'll make it decrease the count. I'll hit save again, and now when I rerun, we will see, oh, it's lost its connection to the browser. That's nice. Occasionally, Karma does this. All you have to do is just kill the browser, and then it'll immediately create a new one and reconnect to it. Anyway, now it's working, and we can see we've got 2 of 2 tests passing, and we've just test-driven this tiny little feature there, and everything works. And if we want to see it actually in a browser, well, you can see that hot module replacement has kicked in, and it's already appeared in the browser, and we can now start to see the button actually work properly. OK, so there we go. We have done a little bit of tests in our application. And that's some of the functionality that's built into these project templates. Now, some of them have got more features than others. Like I said, Angular is the only one with tests, and Angular and Redux are the only ones with pre-rendering, and so on. Bit of variation, but they've all got mostly the same behavior. And that's the sort of friendly, out-of-the-box experience. But now, let's dig a little bit deeper. Let's see how some of this stuff is working behind the scenes and how we can change and customize it to do slightly more advanced things. And the first thing we'll talk about is Webpack. Now, I've mentioned Webpack repeatedly, but I haven't really shown you anything about what it's doing internally. And that's what I want to do now. Some people think Webpack's a bit scary. Well, it's just the config syntax is a little bit scary, but actually what it does is very straightforward. So I'm going to talk you through some of how it works, but first, let me just show you the actual Webpack configs that we're using here. I'm not going to walk through every line of it, but I'll just show you a couple of highlights. So if I open webpack config.js there, it's quite long. We've got, 71 lines of configuration there. And some people just freak out about that and go, 71 lines just to configure building things? How can that be right? Well, there's quite a bit of stuff that we can control here. I'll show you a couple of them. So one of the things is we're telling Webpack how to handle each different type of file that it can encounter. So here we're saying, whenever you see a TypeScript file, I want you to compile it in a certain way. Whenever we see an HTML file, we're going to use this thing called HTML loader. I'll explain what that is in a minute. This is what we do with CSS or PNG files and so on. So that's telling it what to do with different files. We're also telling it what the entry point for our application is, this TypeScript file here. Now, that is because when TypeScript runs, it's not just searching for all files in a directory to build, but rather it's exploring all the relationships between the different files in your project. I'll explain that in a second. We're also telling it where the output goes on disk, and we're using a few plugins to do things like adding source maps and minifying using Uglify, that kind of thing. Okay, now, there's too much code there for me to walk you through every bit of it, but I'll try and explain at a high level what is actually going on here now. So when Webpack runs, the first thing it does is it looks for the entry point that you have declared. Now, in this example, we had a TypeScript file. It could be a different type of file, but TypeScript is a good place for our application to start, and that's what we're pointing at. Now, Webpack doesn't natively know anything about TypeScript, so we have to tell it what to do with TypeScript files, and we can use a TypeScript loader. The TypeScript loader is a bit of plugin code that tells Webpack how to understand the file, as in how to understand when it has references to other files and how to compile it into whatever we want the output to be, which is JavaScript in this case. So TypeScript loader knows how to detect references from one TypeScript file to another TypeScript file. And of course, TypeScript files can then probably reference some other TypeScript files, and so on. So you've got this big chain of all your TypeScript files referencing each other in a big kind of tree shape. And that's kind of what you'd expect in your application, right? But TypeScript is not only limited to referencing other TypeScript files. You could, for example, have a reference to a JavaScript file, and that JavaScript file might even be in an NPM Node Package Manager module. And that's a very common scenario because that is how you would be referencing Angular or React or whatever. You'll be getting the libraries from NPM and referencing the JavaScript files in those. Now, Webpack does natively understand JavaScript, so it knows how to recognize when one JavaScript file references another. And it could be another file in the same module. It could even be a JavaScript file in a completely different package. And that's fine. You can have references that produce an entire chain of packages referencing other packages, and Webpack can explore all of that. Now, here's where it gets a little bit more interesting if you haven't seen it before. You might not expect it. But TypeScript files could reference any other type of file, not only just JavaScript. You could even, if you wanted, reference an HTML file from your TypeScript file. So why would you do that? Well, for example, in your Angular component file, you probably want it to reference an HTML template. And so that's what's going to happen here. And although Webpack doesn't natively understand HTML, we can use the HTML loader, which tells it how to understand the file and recognize references to other types of files, for example, CSS. And then the CSS loader could understand that and recognize that we've referenced from there some other CSS file, and from there maybe even an image or anything else. It doesn't matter. Webpack is going to explore all these relationships, and depending on how you configured it, it will do different things with the files that it finds. For example, with a PNG file, you might want to bundle that file into your JavaScript as a big blob of base 64 data, Or you might want to treat it as a file on disk that gets loaded via an HTTP request. You can configure that in your Webpack config, whether you want to load it from a file or whether you want it to be encoded as a URL in your bundle. You can just configure that. And you're not even limited just to referencing well-known types of files. You can make up your own completely custom type of file if you want to. As long as you implement your own loader for it, then Webpack can understand the relationships from there to other types of files and so on. So this is how Webpack can explore the entire chain of dependencies through your entire application and build up a picture of what files you're actually using. So what does it do with all that information then? How does it actually produce some bundles on disk? Well, again, that's just a question of how you configure it. So one thing you might remember from the Webpack config I showed you just a minute ago is that we were using some plugins. And plugins can take this representation of your application in memory and transform it in some way. For example, they might minify your code. And the minifier doesn't need to understand TypeScript or ES 2017 or anything like that. It's just going to take the output from all your loaders and then it minifies it. So it can minify any kind of input. It's all completely separated concerns there. You can have another plugin that splits out files into different bundles that get loaded on demand and so on. You can set up whatever kind of output structure you want using plugins. And then it will emit the result from all of that as some actual files on disk. Usually you'll have a main JavaScript file, but depending on how you've configured it, you might also be emitting some separate CSS files, images, or whatever, and they will all go in a directory that's ready to be served to the browser. Okay. So that is basically how Webpack explores all the relationships in your application and emits it as some bundles that you've configured onto disk. Let's have a go at actually using it, shall we? Let us change our application a little bit to change the Webpack config and give it some new functionality. And the specific example I want to do here is adding support for compiling Sass files. So Sass is a dialect of CSS, I suppose. It's a styling system, and it compiles down to CSS. And there's no support for it in these templates out of the box, but we can add support very easily just by changing our Webpack config. So let's say we want to add that to this Angular application. Imagine you've got some designer working on your team, and your designer gives you a Sass file and says, that's the way this counter component should be styled. So let's add a Sass file here. I'm going to go add new item here. Now, I don't know or care whether Visual Studio has support for Sass. It doesn't really matter to me. I'm just going to make a text file called mystyles.sass. Okay, so I've got this empty text file, and I'm going to put in a bit of Sass code in there. Now, I'm sure that your designer on your team can do a better job of styling things than me, but I'm just a developer, and from my point of view, this is a pretty good way of styling something. So I'm defining this variable, myColor, which is green, and I say everything should be my color. Everything should be as I like it, and I like things green. Okay, so that's my style file there. Now, if I want to use that in an Angular component, the correct way of doing that in Angular is to go to where your component is defined and say style URLs, and we'll give it an array of the file names of the style files that we want to use. So in this case, I'm using mystyles.sass, not CSS, delete that, Sass, okay? And I'll hit save on that. And hopefully the hot module replacement will kick in. Oh yeah, it has. And it immediately says, I'm sorry, there's a problem with that. You're trying to use mystyles.sass. We don't know what that is. You may need an appropriate loader to handle this file type. Okay? So we need to tell Webpack how to deal with Sass files. Now, what you'll do is obviously you'll go to Google and you'll type Webpack Sass, and the first thing that comes up will tell you that you need to install a Webpack plugin called Sass Loader, and that deals with loading Sass. So I'm going to do that. I'll say npm install Sass Loader, or if I had an internet connection, I would, but I don't need to because I've already installed it. Okay? And that would give me the ability to compile Sass. And then I would go to my Webpack config, and I would say, okay, in this list of how to deal with different types of files, I'm going to also say, when we have a Sass file, we'll use the Sass loader. So let's put that in here. I'll say, all right, whenever you see a file name that ends with Sass, we want to use Sass loader. Now, loaders can be chained together. So they don't all have to do everything. They can just do one small job. And the one small job that Sass loader does is it converts Sass into regular CSS. That's all. And when it's been converted into regular CSS, we can use the CSS loader to enable Webpack to explore its relationships to other CSS files, maybe ones that have been compiled by Sass, it doesn't matter. And then, after that, we want to chain this with the toString loader. Now that's a bit weird, but that is an Angular-specific thing. When Angular sees references to these Sass files, it wants them to be provided as strings containing the CSS markup. So that's what the toString loader does. It just converts the CSS to a simple string that can be passed to Angular. Okay, so I could now run Webpack. I'm going to run it from the command line here just to show you we don't only run Webpack through hot module replacement. We can also run it on the command line. And if I run it from the command line now, you'll see I'm not getting any errors anymore. I did have an error last time. I do not have errors now because Webpack now knows how to deal with the Sass file. So if I come and restart my application, which I have to do when I change the Webpack config, we don't have hot module replacement for the Webpack config itself. When my application comes back up and restarts, this time it will not have a problem with Sass. It will just use the Sass properly. So now my counter component is green as I like it. Okay, so that's good. But because Webpack is a very modular system, all the different parts of Webpack are still going to work, even though it didn't know about Sass before. So for example, I'm still going to get hot module replacement, but now on my Sass file. So if I go in here and I change this green to red, and I'll hit save on that, then in my browser, it changes to red immediately. So it all just changed together very nicely. If we want it in blue, yeah, I think I probably prefer the blue. Okay, so all of this stuff just works together, and we get immediate updates when we change our Sass files now. Okay. Right, that's an example of how we can extend our build system just by adding a little bit of Webpack config. And there's loads of other things you can do with Webpack, whether you want to change the way that stuff gets outputted, minified, bundled, whatever. You can read loads of web pages and blog posts and stuff about stuff you can do with Webpack like that. Fine. Last thing we're going to have time to talk about is we're really going to get under the bonnet now, under the hood, whatever you say, and see how some of this stuff works behind the scenes using this library called Node services. Now, if you think about it a little bit, you will realize that quite a bit of the stuff that I've shown you so far has relied on being able to execute JavaScript on the server. So in order to do the Webpack integration, to flow Webpack compilation output through ASP.NET into the browser, we've needed to be able to run Webpack and all the JavaScript parts of that on the server. Similarly, for the pre-rendering, obviously we needed to run your Angular or React components on the server there, even though they're JavaScript. So how can we run JavaScript on the server in a .NET environment? Well, that's what Node Services gives us. So when you have been using an application with this template, your application has been doing things like pre-rendering or Webpack middleware, and it does that by means of making calls into a NuGet package called Microsoft ASP.NET Core SPA Services, which just got released in its sort of fully RTM'd state just about a month ago. And that contains ready-made logic for doing all this sort of stuff. And that, in turn, needs to execute JavaScript, and it does so by calling another NuGet package called Node Services. And that is a general-purpose way of running JavaScript on the server in an ASP.NET application. And the way that works internally is using Node.js. So it spins up hidden instances of Node.js and has got a very fast and robust way of sending calls into it and getting the results back, dealing with errors and crashes and all that sort of stuff, so you don't need to worry about it. So if you wanted, you could use Node Services on its own. Even if you're not building a single-page application, you could just, for some reason, choose to run JavaScript in the middle of your ASP.NET application on the server, if you wanted. But why would you do that? I mean, that seems like a fairly crazy thing to do, doesn't it? Well, the primary reason you would want to do that is if you want to use some third-party package from NPM. So NPM is the Node Package Manager. It's the largest collection of open source packages there is, and there's loads of useful stuff on there, and you might well want to use that in your application. And I'm going to show you an example of that just now. So let's have a go at executing some server-side JavaScript separately from all this single-page application stuff. And the specific example I'm going to show you now is doing some server-side image manipulation. Now, there are ways of doing image manipulation on the server with .NET Core, but it's still a bit early days for that, whereas there's loads and loads and loads of powerful ways of doing that with NPM packages. And so I'll show you a way that we can just pull in one of those and use it. So I'm going to switch over to this other ASP.NET Core application. This is not a single-page application. It's just your regular, bog-standard, boring, file-new ASP.NET MVC project, which looks like this. And all I've changed with this is over on the About page, we've got this little message that says, add a cool picture of something from Wroclaw here. OK, fine. So we'll have a go at adding a little picture. And you might think, hey, that's not difficult, right? I'm a web developer. I add pictures to web pages all day, no trouble. Well, OK, it's not that difficult, but let's just do it, and then we'll come up with some excuse for doing server-side image manipulation. So we'll go into the place where that view is here, and I'll click the mouse correctly, and it will open, OK? And we'll see here's that markup that says add a cool picture here. All right, so I've already got some pictures that we could add. Let's have a look, see what we've got. I've got a couple that we could choose from. We've got this nice picture of the town center, which looks really cool. Or we've got a picture of one of these funky things. I don't really know what these things are for, but they are everywhere. I assume they're really important. I don't know. I've been trying to find out. But anyway, let's have a picture of one of these gnome things in the middle of the page there. So how are we going to do that? Well, the most basic way we could do it, if we're using VS, is to just drag the image straight into the view there, and it will generate this image tag for us now. So does that work? Let's find out. We'll go back, and we'll hit reload, and we'll see if our gnome appears. It does not appear. That's strange, isn't it? Why didn't it work? Well, if you see the scroll bar, you might be able to realize why it didn't work. It's not really the right size to fit in with the page. OK, so we've got a bit of a problem there. We could fix that in various ways. We could say, let's have a width attribute like this, and then when I go back and hit reload, it now occupies a sensible portion of the screen. But still, that's a bit rubbish as a solution, because we're still sending the whole massive image down to the browser. And if you want to see how big that is, we can see that that image right now is 1.9 megabytes, which is really, really wasteful. We can do better than that. So we want to make this a smaller image. Now, if we wanted, we could just fire up Photoshop or Paint.net or whatever and resize the image that way, but that's boring. Real developers don't do that. Real developers do dynamic server-side image resizing. So let's do that, shall we? Okay, I'm going to delete this width attribute, and I'm going to change the URL a little bit. So we'll reference this URL, resize, and then we will point to the image. Now, there isn't actually anything listening for these requests right now. Nothing listens for requests that start with resize. So if I reload, I expect that's just going to return a 404. And it does, you can see. I've got a broken image tag now. And if I open that in a new tab, you can see that when we reference this resize URL, the server is responding with a 404. Okay, so we need to put in a bit of logic to actually handle that request. So I am going to go to my controllers here and put a bit of controller logic in. I've got this controller called resize image controller. Doesn't have any logic just yet. Let's put in some logic to resize images. OK, now what am I going to do? The first thing I'm going to do is add a method that looks like this. So let's just step through this. Firstly, I'm telling ASP.NET that I want it to respond to all URLs that start resize and then slash and some other string there that is the image path. And I'm saying, OK, this is an asynchronous action. It's going to receive that image path. It's also going to receive from the command line a width argument, or maybe it doesn't, in which case we get a default value of 300. And we're also saying we want the dependency injection system to give us an instance of iHosting environment. So what's that? And why do we want it? I'll show you. Here's a little bit of initial logic. The first thing we want to do is find the actual file on disk. And this is where we're using the hosting environment. We're saying, hosting environment, please have a look in the www root directory and try and find a file that matches this image path. And if that file does not exist, then we'll return 404 not found. But if it does exist, then we'll return a message to say that, yes, we do know what that file is. Let's check that that works. I'm going to reload. And hopefully, instead of a 404, we'll now get this message that says, OK, we've found an actual file on disk that we want to resize. Now, like I said, it's probably possible to do the resizing with native .NET Core code, but I want to show you how we can do it with an NPM module. So I want to have a reference to inode services. So from the from the dependency injector, I'm going to say, please give me an instance of inode services, and we'll call that node services. And when I've got that, I can now execute JavaScript code on the server. I can say things like this: node services.invoke async, and then we can call some method, some JavaScript code on the server. So here's my initial stab at that. I'm going to say, we're going to get node services, and we will tell it to invoke asynchronously this JavaScript file, resizeimage.js. That doesn't exist yet. I'll add that in a minute. And we're going to pass to it a physical path of the file to resize, and also the width that we want it to resize it to. And the return value is going to be a string. And we'll get that asynchronously, so we'll await for it. And finally, we will just send that string to the browser. Now, resizeimage.js does not exist yet. So when I reload, I'm going to get an error. It'll say, I'm trying to find resizeimage.js, but it's not there. And so you see, look, cannot find module resizeimage.js. OK, let's add to that file then, shall we? So here, I'm going to say add new item and JavaScript file. I'll call it resizeimage.js. And I can put whatever JavaScript code I want in here to execute on the server. And I'll do the image resizing in a second, but first, let's just do a bit of a hello world message. So this JavaScript module is going to export this function, and all it does is it builds this message that says, hello, the current time is this value, and we'll send it back via this callback. We'll say there's no error, we're just giving you this message. So now, if I come back here and reload, then our JavaScript code will run on the server, and we'll get this message back from Node in the middle of our MVC action. And every time I hit refresh, it's going to update immediately. Great. So now we can write some arbitrary JavaScript code. And since this is a real Node environment, we can pull in any NPM module we want. Anything that we like, it's going to work fine. So let's say I want to do some image resizing. I'm going to use a very popular NPM module called Sharp. Sharp is really powerful, it's very fast, it's very robust, and it makes it very easy to do things like image resizing. So my JavaScript code now says, let's get a reference to the Sharp package there, and I want to receive from .NET Code the physical path and width, and then I'm going to say, Sharp, please load the image from this physical path, and then resize it to this max width, and then pipe the binary data back to the .NET Code as a stream. So then back in my .NET code, I will say the return value now is not a string anymore, it's now a stream. Okay? And to send that back to the browser, I need to change the response a little bit to a file, and then I'll give it a content type of image, JPEG, right? And so then, back in my browser, hopefully, when that request comes in, we will pass it off to Node, we will do the image resizing, and we will actually send the image back down to the browser. And then I can do things like dynamically get it to be different sizes. So I'm going to change this to width equals 150, and you'll see that the image now becomes much smaller. Just to prove that really works, over here, I'll reload, and then if we look in the network tab now, we will see that this image has gone down from 2 megabytes to 24 kilobytes. So that's obviously it's really working there. Great. Right, what was the point of all that then? The point of me showing that is not particularly because I think that you should be doing your image resizing this way. I mean, it works, it's a perfectly good way of doing it, nothing wrong with it, that's fine. But the real point of it is just to show you that you can use arbitrary NPM modules in a very straightforward way in the middle of your ASP.NET Core application if you use this Node Services package. And it's not particularly unnatural, it just works quite nicely. And that is the thing that has been underpinning all the other stuff that I've shown you. That's how we've been able to do the Webpack integration and the pre-rendering and a whole bunch of other stuff. So we are running out of time. In summary, what we have talked about in this talk, we've talked about the ready pre-boxed experience of creating a single-page application with these templates, and I've shown you various features that are in there. I've also shown you a little bit of how you can get into the internals, how you can mess around with the Webpack config, and how you can use some of these components on your own in a different application if you want to. So that's all we're going to have time to talk about today. If you want to learn more about this stuff, you can go to this GitHub repo here. That's not just for this demo, that's for the actual original source code for the part of ASP.NET that I've shown you here. You can see all the original source, you can see lots of documentation, and you can send us some issues and pull requests and so on. And if you want to ask me any questions, I'm going to be around today. You can send me a message on Twitter, and that's all we're going to have time for. So I hope that you enjoy the rest of your day, and Jen Kuye to you all.